everyone's having a good and happy Valentine's Day. My wife sent me a couple of more World of Engineering problems, and I find them interesting. Now, what I like to do with some of these problems is to look at them a little differently. Now, this one's pretty straightforward. So if you're a geometry teacher, this would probably be given very early on the year, depending on what you want to do. So you're just finding the area of the shaded area. And they already told you it's a square, so we know we have right angles here. These are all right angles, okay? But imagine if they didn't, you would actually have to go prove it, which can be a little bit of a challenge. So maybe if you want to make the problem a little more complex, just say the colored region. And they're going to assume it's a square, but they can't do that until they prove it. So they can either prove it by all sides being equal, which is easily done using the Pythagorean, and then maybe that the diagonals are equal because if you're given a rhombus and the rhombus diagonals are equal, then you have a square. All right, so that's just one way to go about doing it. But given this problem right here, this is a fairly elementary problem because if we do area of the big minus area of the small, it's pretty easy. So we have a square here because these are all equal. And so we have 8 times 8, which is 64. So the area of the big is equal to 64. And area of the shaded is equal to area of the big minus 4 times the area of the triangles that are here. 1, 2, 3, 4. These 4 congruent triangles. So that's pretty easy to do. 1/2 base times height gives you 3 times 2. So each of these areas are 6. All right. And so 6 times 4 is 6 times 4 is 24. So 64 minus 24 is equal to 40. Okay, 40 square units. Square units, however you want to do it. Don't know if they're inches, meters, miles, centimeters, whatever. Okay. Now, if you want a little bit more of a challenge and say you're doing high school geometry, this may be a middle school geometry. There's a bit of a difference. You may require them to say use the area of something else. You can say use trig. You can say use the area of a rhombus, which is equal to 1/2 d1 d2. That forces them to find the diagonals. Okay, and then no calculator. That forces them to use radicals, which are always fun. Okay, because you have 2 squared plus 6 squared, and that's going to be 4 plus 36 is 40. So this length right here is square root of 40. Square root of 40, because we know it's a square, square root of 40, and square root of 40. Okay. Shoot, you can use Brahma-Gupta's formula if you want. So there's a lot of different ways to do this. But let's specifically say you want to find the diagonals. So you now have 40 squared, which is nothing more than 2 root 10 if you want to simplify your radical. But since you're not done with the problem, you want to save your simplifying radicals until the end. All right. So we want to find this diagonal 1 and diagonal 2, and they're going to be equal because it's a square. So we're just going to do another a squared plus b squared equals c squared type thing. All right. Actually, no, it'd be much easier. Say if you want to do 45 special rights, that would be so much easier. So you just, when you draw a diagonal on a square, this is 45 degrees, 45, and we already said this is root 40, right? So root 40, and since we have a special right triangle, I can't even draw 45, 45. This is only like the 3rd time I've used this writing tablet. You have a root 2, okay, 445, 45. Not quite there. I made it worse. Okay. So if this is 45, 45, and your sides are a and a root 2 is just going to be square root of 80. All right. And now we can simplify. 16 goes in the 85 times, so you got 4 root 5 as your diagonal. That's a 4 root 5. So D1 is 4 root 5, 4 root 5. And when you multiply those out together, that's going to be 1/2. So 2 times 4 is 8. And then 5 times 5, square root of 5 times square root of 5 is 5. So you're going to have 4 times, no, 8 times 5, right? 8 times 5 is 40. So you're going to get the exact same thing. Alrighty, so it just depends on what level your students are at that you may want to restrict how they do it. If you're in the trig unit, make them use trig. And that can be a lot of fun as well too. All right. So this looks like a very easy problem, and it is. I would give it to your basic, maybe middle school geometry. But if you want to, you can tailor these things how you want. Now this one's a lot more fun. She sent me this one on top of the other one. And I looked at this and I said, well, let's see, how do I want to do this? And again, when you see these right triangles and you're given two sides of the right triangle, you can do a squared plus b squared equals c squared. So that's 5 squared plus 10 squared. 25 plus 100 is 125. Square root that. So this is root 125. Now I can simplify that. 25 goes into it 5 times, so that's just 5 root 5. All right. But let's don't do that just yet, because I see something here. Now you can say use trig to solve this problem. So you're going to try and find theta here and beta there. You're going to try and find these angles, which you can do by doing a little bit of trig. But what I like about this problem is that it is actually, let me go up here, pick this. If you drop an altitude right here, you've got yourself similar triangles, geometric mean problems. Now you do typically geometric mean right before you start doing 45, 45, and 30, 60, 90 special right triangles. All right, so you got a similarity situation going here. You have 3 triangles. You have this little one, medium one, and the big green one. They're all similar triangles. And by dropping this altitude and having a right angle, I know I have a rectangle, so this length is 5, and I know this length is 10. So let me redraw. Let me see if I could do this without causing a problem. Let me draw another triangle here, okay? And I'm going to boop and boop, okay? This is my green triangle. And I have my altitude right here. Yes, right there. Okay, and I know this is 10, and I know this is 5, all right? So I'm looking for this. Let's call that x. We have a geometric mean, 5 being our mean, and then we have these two lengths right here. So one method that is taught in geometric mean is a proportion. It's not the only way to do it. I put my 5 and 5 here, and my x here, and my 10 here. And you just cross multiply, all right? So you're going to have 10x is equal to 25. So 10x is equal to 25. X is equal to 25 over 10, or 2.5, okay? However you want to do it. Or let's keep it as a fraction since we're doing algebra. That's going to be 5 over 2, all right? So this length is 5 over 2. So now we have a triangle here where I have the altitude and a base. The base is 10 plus 5 over 2. All right, this is a mixed number. All right, so 20, 25 over 2, something like that. Okay. So what we're going to do is go ahead and do 1/2 base times height. My base is this length right here. So it's going to be, what did I say? It's going to be 25 over 2. And we're going to multiply by 1/2, so that's 25 over 4. I'll do it over here. 25 over 4 times 5. All right? So that's going to be 125 over 4 is my area. And that's going to be 31 point something, 31.25. Is that? I'm doing my mental math, so somebody better check that for me, all right? I have a calculator somewhere in this office. I don't know where, but I'm sure I have one somewhere. Or if I gave it to my daughter might have stole it. Alrighty, so that is one way to do it. So geometric means a fun way. Again, trig would be another fun way to do it. Maybe I'll redo this one as a trig problem. I kind of miss geometry. I've been subbing mostly history and pre-cal, which I love pre-cal. Pre-cal's a blast. But we don't get into some of the fun geometry problems. Alrighty, until next time.